Hello everyone, my name is Barbara Friesen and today I'll be going over my code for pathfinding using a star algorithm. I'm going to start by showing you my node class here. So up here I have all the variables that it contains. It keeps track of its neighbors using an array list, which is a bunch of arcs, which we'll go over in a second. It keeps a previous node, which will help us when printing back the path that we found, along with the name, which is the variable that we're going to be using for it, and the city as well for more ease of access for printing it out. The H heuristic is also calculated and kept, along with the F value and the G value, which if you're not familiar with A star, the G is the cost of the arc itself, um, in combination with the previous costs to that node point, while f is that cost plus the heuristic. So we have a basic constructor, and then the arc just has its own cost as well as the node that it's associated with as well. This arc object gets created when add branch is called here, which as you can see creates a new arc object, giving it the cost and the node that it's attached to, while also adding that node to the list of neighbors so that can get recalled later. As for our heuristic function, it's pretty much just the arc cost minus the heuristic that we calculate, which is just a random number that is between 5 and 10, which is created at that point here in the node constructor. So the rest of this in our main methods here is pretty standard: instantiating, adding all the hard-coded branches with their costs. And here we have our input system. We just simply use a scanner. We have a check if it's valid function that we call, as well as translating it into a node so that we can pass it to our find path, which is right down here. The check if valid is just a kind of brute force way of doing it, and same with the finding a node, which will return the node that the abbreviation that the user inputted associates with. The algorithm approach is rather simple. We start with two priority queues, and one is visited and one is unvisited, so a node can only be in one of those queues. We start with only the start node in the unvisited, and then it'll go into a while loop that will run until unvisited is empty, pretty much. First thing this while loop does is check if the current node that it is on is the goal node, in which case it will terminate. And then if that is not the case, it will go through every arc that's associated with the nodes using the neighbors and check their weights first. And then if it is not in the unvisited, and if it's not in the visited, then it will process these costs and then add that into the unvisited so we can consider that to be the next node that we explore based on the cost. The previously explored node is then removed from unvisited and added to visited so it won't be gone over again. If no solution exists, it's just going to return null. But if a solution exists, it returns the goal node, which it gets then sent to print solution, which just pulls the city names that we went over in the node into a path array list and just very simply prints it out. I will show you quickly a demo of this. So I'll pull this up here, and as you can see, it asks which ones you want here. So let's say we go RI for we want to go from Richmond, and let's say we want to go to Hope. Okay, so the shortest path from your start to your destination is from Richmond to Delta to Langley to Abbotsford to Chilliwack and then finally to Hope. And that is everything. I hope you guys have a great day.